So what we have seen in previous slide was values of variables. Putting this condition, initial condition x1, x2, x3, 0, we have seen that we are getting this. We have already seen in previous slide. S1 as equal to 8, S2 as equal to 10, and S3 as equal to 15. This is our initial solution. And if you recall, in previous lecture we have seen body and identity part of the matrix. We have seen body and identity part of the matrix. Now what we will be doing? We will be putting this data in the form of simplex table. If you recall, in simplex table we have seen there is one Cj row, Zj row, like that. So we will be putting those values here. So now you know that we are having 3 basic variables. So here I am writing x1, x2, x3. This is x3. Second column value S1, S2 and S3. This row, if you recall our last discussion, it is referred as Cj row. It is referred as Cj row. And here we will be writing value of quantity for current variable in solution. Value of quantity for current variable solution, and we will be writing here the corresponding value in the form of EI for current variable. That we will be discussing over here, how to put this data in simplex table. If you recall, I have said that real variable form is representing body part and this is representing identity matrix. So equation wise we will put the data over here. So CVS, initially CVS are S1. CVS is also referred as basic variable. This is also referred as basic variable. So our first variable is S1, second is S2, third is S3. This is clear. What you have to put under this basic or current variable in solution is the initial answer which you are getting. Here I am writing quantity, means this quantity 8, 10, 15 of respective variable. So 8, 10, 15. Getting? And now this is important. See here, this S1 is the product of equation number 1. So we have to write structural coefficient. These 2x1, 2, 3, S1's coefficient 1, they are referred as structural coefficient, Aij. So here we will write for this x1, for first equation it is 2, then 3. See, there is no term of x3. Since it is missing, we have to write 0. There is only S1 term, so 1 into S1, no term, so it will be 0. I think it is very clear. For second, there is no x1 term, so it will be 0, followed by 2, followed by 3, then second, we are discussing second. For second it is 2x2. For second it is 2x2. So under x2 we have to write 2. There is no x1 term, 0. For x3 it is 5. There is no s1, only presence of s2. So 0. Coefficient of S2 is 1, absent of S3, so 0. Second equation. Third equation, you are having all 3 terms x1, x2, x3 with coefficient 3, 2, 4. 3, 2, 4. Got it? Only S3. So no presence of S1, S2 in this. So 0, 0, 1. See this 1, 0, 0, 0, 1, 0, 0, 0, 1. We have seen in our earlier semesters, this is called as identity part, which is represented in the matrix 1, 0, 0 or 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, like that. So this is identity part, this is main body part. Now we have to write these Cj values from standard form. This standard form we have already written in our previous slide. So here it is, what I have to do is, I have to write the coefficients of x1, x2, x3, s1, s2, s3 from standard form in this Cj rows. So it is 3, 5, 4, 0, 0, 0. Got it? This is how you have to fill simplex table. I am explaining this in elaborate manner so that in next slide you will come to know how the values taken in table, I have taken the direct table, how those values arrived you will get from this logic. And this EI will represent the same coefficient for these variables representing basic variable. So amongst these variable, which are representing basic variable, S1, S2, S3. The coefficient of Cj coefficient of S1, S2, S3 is 0 will be same as EI 0, 0, 0. Suppose in next iteration in algorithmic process, here x2 comes, suppose I am saying suppose x2 comes, the EI value for x2 here will be 5. Got it? Now what we have to do? We have to calculate two more rows. One is Zj row and other is Cj minus Zj row. These rows we have to see, we have to calculate. And now this particular row will be the deciding factor whether the solution, which initial solution which we are saying S1 is this quantity, S1, S2 is this quantity, it will decide whether this particular solution is optimal or not. This particular value, this is represented, decided by Cj minus Zj row values. We have discussed in our previous lecture. I will explain you how to find these values for few cases. Here, if you recall, this Zj is nothing but it is summation of A I j into E I. How that you are getting, I will explain. Summation, addition, first multiplication of two terms, Aij, all these values represent Aij values. In a simplex matrix, these are EI values. So for getting this value, first value under x1, it will be summation of Aij into EI. Listen how you are getting this value. 0 into 2. 0 into 2, product will be 0. Summation plus. So 0 into 2, 0 plus 0 into 0, 0 plus 0 into 3, 0, 0 plus 0 plus 0, 0. So overall you will get 0. Now if you apply logic, if all values of EI are 0, if all values of EI are 0, then all values under Z0 will automatically be 0. So our calculation of Z0 is over. Now we'll see how we calculate Cj minus Zj. This is Z0, this is C0. So simple. Difference of these two values for this x1. So it will be 3 minus 0, 3, Cj minus Zj, 3 minus 0, 3, 5 minus 0, 5, 4 minus 0, 4, 0 minus 0, 0, 0. This is how I have explained in detail how the calculations of simplex table up to net evaluation index row is calculated, which is referred as Cj minus Zj row for making decision. Now if you concentrate, our objective function is maximize, and we have seen the condition in last lecture for solution to be optimal. All, if you recall my last lecture, for solution to be optimal, all Cj minus Zj row values for maximization has to be 0 or negative. That was the condition for solution to be optimal. If there is any single positive value in this particular row, solution is not optimal. So here you can find these three values, 3, 5 and 4 are positive values. They are not satisfying this condition. Means this solution S1 equal to 8, S2 equal to 10, S3 equal to 15 is not optimal. We have arrived at this conclusion. This is not optimal. If this is not optimal, definitely further improvement is possible. It's but natural. When we say solution is not optimal, further improvement is possible. Further improvement is possible. So we have seen also the steps that we have to select from this largest positive value from available positive value. So here amongst 3, 4, 5, 4, the largest is 5, and we have discussed it indicates something. We have to select this as a key column, which will indicate the now, which is giving us hint that in next iteration variable x2 will be entering into the problem. Students, only 3 places are available. See here, only 3 places are available. If one is coming, somebody has to leave. Say we are seeing that this is coming into the problem, and if you recall, we have discussed in our previous lecture that it is represented as key column. Means x2 will be incoming into the problem. We are having 3 variables, s1, s2, s3. s1, s2, s3. 3 positions are available. One man is coming, one variable is coming, x2. So somebody has to leave. And if you recall, for that in step we have studied, we are calculating theta value, which is nothing but it is bi upon aik. The meaning of b is this quantity is represented as b, suppose. So value of b value of B is quantity 8 upon kth column AI value. Kth column AI value. So it will be 8 by for this kth column Aij is 3. So it will be 8 by 3. Then 10 by 2. 10 by 2. Then 15 by 2. 15 by 2. by 2. How these values I have written? Again, listen carefully. Ratio BI upon AI values of kth column. We have identified this column as kth column. Key column. KC stands for key column. For key column, AI values are 3, 2, 2. 3, 2, 2. Their respective BI value. I stands for rows. I stands for rows. J stands for column. For this value of AI, for K column, BI is 8. 8 by 3, 10 by 2, 15 by 2. Now we have to find which is the minimum. So here the ratio is suppose 5, here 7.5, and here it is 2 point. It is not exactly 3, 2 point suppose 7 or 8 arbitrarily. It is definitely not 3. It is 8, 9 by 3 will be 9 by 3 will be 3. So definitely it is less than 2.8. Amongst these values, we have to see which is the smallest positive theta. If you compare these values, the smallest positive theta is this one, which is representing S1. So now you can see here, one variable is S1, other variable is X2. This is very important to understand. This variable we have got through this key column. This variable we have got through this row, which is referred as, this row is referred as key row. Key row. So I have pointed this towards X2. I have given this direction to S1. So this is for indication. Then in next iteration, our first solution was what? S1, S2, S3, 0, like 8, 10, 15. Now in second iteration, place of this S1 will be taken by, guess, will be taken by X2. This is very important. In next table, this S1 will be replaced by X2, and we'll continue with this process till we get optimal solution. I think it is clear. So now we'll move ahead. This is all basic. Let's move ahead. This I have introduced, explained everything. Now we have seen how to convert and everything that we have discussed. See here. If you recall, we have discussed this table in previous slide, where I have said, if you remember my discussion, my dialogues, I have said that this as KC and pointing towards X2, and we also discussed 8 by 3. If you recall, it is a minimum ratio. So this I have represented as K R, and I have explained in previous slide. In next iteration, place of this S1 will be replaced by what? X2. Now the intersection point of key column and key row is referred as key element, and here key element is 3. Intersection of key column and key row. Intersection of key column and key row 3. What is the step we have studied in last lecture? We have to convert this key element into unity 1. So key element is 3. How I will convert key element 1? If I divide 3 by 3, 3 by 3 is 1. Now remember, if you are dividing these 3 by 3, you have to divide all values of this row by 3 to avoid disturbance to the other values. So here you can see it is written new R1, R1 means row 1, new row 1, this is row 1, row 2, this is R1, this is R2, and this is R3, R1, R2, R3. Getting? What we have to do? R1 old, this is R1 old. What we have to convert? These 3 into 1 key element. So R1 old divided by 3. What is 3? 3 is key element. So you get R1 new. So see, this is 8 by 3 first value, second 2 by 3, third 3 by 3, fourth 0 by 3, 1 by 3, 0 by 3, 0 by 3. This is change new R1 row. This is change new R1 row. Clear? Important. If it is 1, if key element is 1, no need to convert it into unity because already it is 1. But if it is other than 1 value, remember you have to create new row for that particular key element. And simple step is divide all values of that particular row by key element value. Simple. Now students, if you are changing values of this row, first row, now see, this is simultaneous equation process. These values of R2 and R3 are applicable only if R1 takes these values. But now what you did? You have changed the values of R1. This is very important. You have changed the values of R1. So it is necessary to change corresponding values of remaining rows, and remaining rows are R2 and R3. If you recall, in last lecture we have seen a formula, new row element is equal to, we have discussed that formula, and I have said I will apply this formula in actual solving of the problem by simplex method. So here I have applied that concept of the formula which we have discussed in last lecture. So now new row values which we have discussed in last lecture, the formula R2 old. What we have to do? R2 old values minus 2 times. Why it is 2 times? Because it is the element at the intersection of key column. See, now I am talking of, for R2 I am talking of this particular 2. I am talking for this particular 2. 2 into R1. R1 values are these values. Similarly for R3 old means all these old values of R3 minus 2 times R1 new. Now one thing, these two is these two is very important, and friends, these two is these two. Suppose here it would have been 3, we would have write 3. This would have been 4, we need to write 4 over here. So whatever these values are, the values at the intersection of key column and row being replaced. Multiplication values are values at the intersection of key column and row which is being replaced. One thing you have to remember, you are not supposed to find these values in decimal fraction, though you are using calculator. You do not calculate these values in the form of 0 point something or 1 point something, 2 point something. Let it be in the form of fraction. So by using that logic formula, we have converted key element into 1 and we have changed the values of remaining variable, and now these values we will put in second simplex table and we will find again Cj minus Zj for solution of x2, s2 and s3. We will find these values for the, because s1 will be replaced by x2 and our new values will be equal to, x2 will be equal to given B quantity, S2 will be given B quantity, S3 will be given B quantity. So accordingly we will be getting second simplex table, and again we will find the values for second simplex table. So if you go by that method, see here, this table we got it by doing the same logic. What is that? x2, s2, s3, and the values are, for x2 the values are this 8 by 3, s2 values 14 by 9 and 29 by 3. This is our important improved solution. First solution was not optimal, so we got this improved solution. And now our duty is to go into that loop, find whether this solution is satisfying the condition of index row, that is Cj minus Zj row, as having 0 or negative value. If in that we get any value as positive value, solution will not be optimal. So this problem again we will discuss in next lecture from this point, and we will arrive at final optimal solution for this simplex problem. Hope you got. Now what you can try from your side is apply the same logic, and if you could arrive at a point wherein you get all values, that is values of x1, x2, x3 with satisfying condition. So today we will stop at this point, and in next lecture we will continue from this point onwards to find what is the exact optimal solution. Till then, practice the problem.